Today's lesson is about truth tables and the logical equivalence. Let's talk about some concepts. Propositions are statements which may be true or false. The truth value of a proposition is whether it's true or false. Proposition notation. We present propositions by letters such as P, Q, and R. For example, P stands for 3 plus 4 equals 7. Q stands for summer is hot. R stands for I like reading. Negation. The negation of a proposition P is not P, written as this. The truth value of not P is the opposite of the truth value of P. For example, negation of Q. Q summer is hot. Negation of Q, we will write down this. Meaning summer is not hot. Compound propositions. Compound propositions are statements which are formed using connectives such as and, or. Conjunction. When two propositions are joined using the word and, the new proposition is the conjunction of the original propositions. If P and Q are propositions, then P and Q is used to denote their conjunction. A conjunction is true only when both original propositions are true. In other words, conjunction means and. We use this symbol to show conjunction. The rule for truth table of conjunction, that is to be true, both must be true. Therefore, for PQ, both true, then this is true. Otherwise, rest of them will be false. So remember this rule. For conjunction, to be true, both must be true. Disjunction. When two propositions are joined by the word or, the new proposition is the disjunction of the original propositions. If P and Q are propositions, P or Q is used to denote their disjunction. A disjunction is true when one or both propositions are true. So we can draw a conclusion. For disjunction, that's or, we use this symbol to show disjunction. For the truth table, for disjunction, to be true, at least one must be true. So when you do the truth table for disjunction, remember this rule: to be true, at least one must be true. Therefore, this is true, true, true. Then here is a false. Now let's talk about exclusive disjunction. The exclusive disjunction is true when only one of the propositions is true. The exclusive disjunction of P and Q is written as this. We can describe exclusive disjunction as P or Q but not both, or exactly one of P and Q. For example, I ate apple yesterday. Q, I ate orange yesterday. Exclusive disjunction of P and Q, that is, I ate apple or orange, but I didn't eat both yesterday. Now let's draw a conclusion for exclusive disjunction. That is or, but, not both. Then the symbol will be this. For the truth table of exclusive disjunction, remember to be true, exactly one must be true. Therefore, since this exactly one true for these two, therefore this is true, this is true. Rest of them will be false. Now let's talk about the truth table interpretations. This symbol we call conjunction, meaning and. Rules for truth table will be to be true, both must be true. This symbol means or, that is a disjunction. To be true, at least one must be true. This symbol is exclusive disjunction, means or, but not both. To be true, exactly one must be true. This symbol means negation, not P, the opposite of P. Now let's use this truth table's interpretation to figure out this truth table. Not P means opposite of P. Therefore, check this column. True opposite will be false. True, false. False will be true. False will be true. This means and. To be true, both must be true. So I check these two columns. Both true, it will be true. Otherwise, will be false. This symbol means or. That's a disjunction. To be true, at least one must be true. Still, we need to check these two columns. At least one true means the disjunction will be true. So true, 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 false. This means or, but not both. To be true, exactly one must be true. So we check which one they have exactly one must be true. It's here. This is true. This will be false. False. This is a truth tables. The good part for IB exam, these truth tables are given when you take IB exam. Now let's go to guided practice 1. Construct a truth table for the following propositions. Just check how many symbols you have, then how many extra columns you will have. Since you have two symbols here, therefore, besides P and Q, these two columns, you need to add another two columns like this. So how to construct the truth table? Using the given truth tables for P and Q. For P is true, true, false, false. For Q, they give to you true, false, true, false. Then you will set up negation. That's not P. Then you do not P and Q. Not P, you have to check this column. This is a true. Opposite of true will be false. True, false. False, then true. False, true. Then For not P and Q, you need to check this column and this column. Here is a N, which means to be true, both must be true. To be true, both must be true. Therefore, true, true, here is true. Then rest of them will be false. Remember when you do this, make sure which two columns that you are working on. Now let's go to B. Remember parentheses first. So we do P or Q, but not both. Then you do not P or Q, but not both. See, you have two symbols. That's the reason you have to add another two columns to P and Q. For P and Q, using the given truth tables. So we have true, true, false, false. True, false, true, false. This is a given in this truth table. That's meaning or, but, not both. To be true, exactly one must be true. Exactly one must be true. Therefore, this is true, true. Here's a false, false. Then we're working on not P or Q, but not both. In other words, we need to working on the opposite of this column. So we have true, false, false, true. Let's go to second question for guided practice 1. For the following propositions, construct a truth table for the proposition. Determine whether the proposition is a tautology, a logical contradiction, or neither. Talk about tautology and a logical contradiction. Tautology is a compound proposition that is always true regardless of the truth values of the individual propositions. In other words, tautology means all true in the truth table. For contradiction is a compound proposition that is always false, regardless of the truth values of the individual propositions. In other words, a logical contradiction means all false in the truth table. Let's go to A. Not P and not Q. How many symbols you have? You have 3. Therefore, you have 3 columns added to P and Q. We will do not P, not Q, then not P and not Q. We will set up PQ as a given truth table. True, true, false, false. True, false, true, false. Not P, you have to check this column. That is a false, false, true, true. Not Q means opposite of Q. Therefore, you have false, true, false, true. Not P and not Q. You have to check these two columns. Here is N. To be true, both must be true. So I will check this is true. Rest of them will be false. Since for this column it's not all truth or not all false, therefore it will be neither. It's neither tautology nor a logical contradiction. Now let's go to B. We have 3 symbols, which means we add 3 columns to this PQ. Parentheses first, so we do P or Q. When you have negation, you have to do that first, not P. Then we do P or Q or not P. Copy down PQ from given truth tables. True, true, false, false. True, false, true, false. P or Q to be true, at least one must be true. All you are given from here, that is true, 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 false. Not P, you have to check this column. So you have false, false, true, true. That's the opposite of this P. This is or. That means to be true, at least one must be true. But you need to know we are working on these 2 columns. This is a disjunction. To be true, at least one must be true. So whenever you say true, then that will be true. True, 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 true. Since for these compound propositions, it's all true. Therefore, we call this is a tautology. Now let's go to number 3 from guided practice 1. Use truth tables to establish the following logical equivalence. Let's talk about what's a logical equivalence. Logical equivalence means 2 propositions are logically equivalent if they have the same truth table column. In other words, you need to set up a truth table and show that these 2 propositions have the same truth table. On the left side, we have 1, 2, 3 symbols, so you will set up these 3. On the right side, it's only 1, so we do P or Q. This part, do inside first. Since we have negation, so we do negation first, not P. Then not P and Q. Then we do P or not P and Q. Use the given truth table. Set up true, true, false, false. True, false, true, false. Not P means opposite of P. So we have false, false, true, true. Not P and Q. These 2 columns. And means to be true, both must be true. So we have true here. Then this will be false, false, false. Then we check this column and P, this column, these 2 columns. It's or. To be true, at least one must be true. Therefore, you have true, 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 false. For last column, P or Q you can get from the given truth table. That is true, 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 false. You could see the last column. These two, they have exactly the same true values. That's how you prove these two, they are logical equivalents. Let's go to guided practice 2. Construct truth tables for these compound statements. For these compound statements, we have 3 propositions, P, Q, and R. How to set up this P, Q, R? Go to use this to do P, Q, then repeat. In other words, we have true, true, false, false. Then true, true, false, false. For Q, you will set up true, false, true, false. Then repeat true, false, true, false. For this R, you will set up the first 4, that's true. Then the rest of 4 will be false. Still, you need to count how many symbols you have for these compound statements. Have 1, 2, 3, 4. So you need to get 1, 2, 3, 4 columns added to this PQR. Then do the parentheses first. We have P or Q. Then for these parentheses, you have not R. Then P and not R. Then you have P or Q, or P and not R. For P or Q to be true, at least 1 must be true. Keywords is at least. So we check P and Q, these 2 columns. You can get from here too. You will get the true, 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 false. True, 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 false. For not R means the opposite of this R. Therefore, you have false, 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 false. True, 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 true. P and not R. This is N. To be true, both must be true. Therefore, you need to check this column for the P and not R. To be true, both must be true. So you have true, true. Then rest of them will be false. Last one, you need to check this column and this column. Here is or. To be true, at least 1 must be true. Therefore, you have true, true, true. Here's false. True, 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 false. Let's go to guided practice 2, number 2. Determine whether the following propositions are tautologies, logical contradictions, or neither. We still have 3 variables, so we have P, Q, R. Using this truth table to write down P, Q, R, we have true, true, false, false. Then repeat true, true, false, false. True, false, true, false, true, false, true, false. Then for this R, the first 4 will be true. Then the next 4 will be false. That's how you set up. Then check how many symbols you have. 1, 2, 3, 4. In other words, you need to add another 4 columns to PQR. Then do parentheses first. You have Q and R. Then P or Q. Then not P or Q. Then you have Q and R and not P or Q. Q and R to be true, both must be true. So you need to check this R column and Q. True, true. Then rest of them will be false. P or Q to be true, at least one must be true. So you need to check P and Q. At least one must be true. Therefore, true, true, true. Here's false. True, 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 false. Then we're working on not P or Q. That means the opposite of P or Q. We have false, 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 true, false, 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 true. Last one, we got to working on this and this by and. To be true, both must be true. Therefore, just check, see whether you have both true. No, we don't have. Therefore, you have false, 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 false. Since all false for this compound statement, therefore, this is a logical contradiction. Let's go to number 3. Consider the propositions. P stand for Jake owns a phone. Q, Jake owns a TV. R, Jake owns a laptop. Write down the meaning of Q and R. Keywords is and. So when you write down meaning using and to connect two propositions, therefore we can write down Jake owns a TV and a laptop for Q and R. Let's go to second one. P and Q and R. Keywords will be and. Here's and. Therefore, for P, we can write down Jake owns a phone. And Jake also owns a TV and a laptop. So remember, learn how to use keywords to write down the meaning of propositions.